Hi guys, so we're going to look at a topic in science paper 1, which is physics, and this is moment. In this topic we're going to start by defining what moment is. So we're going to define moment. Then the second thing we're going to look at is we're going to look at some examples of moment. Look at some examples. Then the last thing we look at is what we call the principle of moment. Okay, the principle of moment. Okay, so we're going to start with the first thing, which is moment. So what is moment? So by definition, moment is defined as, so we are saying the product of the force and the perpendicular distance of its line of action from the pivot. So moment is defined as, so we say this is the product of force and the perpendicular distance. All right, so so and the perpendicular distance. Just a minute. Okay, so this one. Okay, so we're saying perpendicular distance. So now our interest here is it's supposed to be from the pivot, so it should come from the pivot. So we can just leave it here. We're saying moment is the product of force and the perpendicular distance, so we can just leave it there. Then what's the other thing you should consider here? So this is what it means. We're saying, so moment is denoted by a capital M. So we're saying moment is equal to the force multiplied by the distance. So that's how we can calculate moment, where we know the force is measured in newtons, then the distance should be in meters. So therefore the moment will be in Newton meters. So the units of moment will be Newton meters. Now, few things that you should know about this is that number one, we are saying the perpendicular distance must be a distance from the pivot to the force. Then the other thing is that it must be at right angles to the force. So look at, let me give you an example. If this is the pivot, it's the pivot, then we have that. Okay, so we're saying it's a product of force and distance. If there is a force that is applied here, then a distance. So if a distance is like that, so if this is the perpendicular distance, then there is a force like that. If you can see, these are forming some form of a right angle here. So now this is showing to say the distance is perpendicular. So like this says moment. It's different if you have something like that. If you have something like that, let's say if the force is coming from that end, then if this is the distance, so meaning this distance is not perpendicular, therefore the moment for this one is equal to 0, then the moment for this one is not equal to 0. So it's very important to take note of those scenarios. However, let us look at an example. Look at an example, we see how best we can look at. Now suppose we have a question here. Then the question is saying calculate. So we're saying calculate the moment, or the force at the pivot. So all right, so now this is a diagram that we have. So we have this diagram, then suppose we have something like that, then we have a force here that is hitting here, and this force is 3 newtons. Then if this is a pivot, so I'm going to say P for pivot. Then we have a distance, a perpendicular distance from that point to that point. This distance is let's say 2 meters. Then how do you find the moment? Now in physics, I want you to be familiar with data. Every time you are asked a question, you should come up with what we call the data. Data is what you have been given. You collect data. So the force that we have there is 3 newtons. What else have we been given? We've been given distance. Distance is 2 meters. Then we're looking for moment. So we say moment question mark, for we don't know what moment is. Then we're going to say moment is equal to force multiplied by distance. Now the force, we have said it's 3 newtons. Then the distance is 2 meters. So when we say 3 multiplied by 2, we get 6 Newton meters. So that is the moment that we find there. So that's how you can calculate moment. So we say the force multiplied by the distance. Now after looking at this, we are therefore going to proceed to look at what we call the principle of moment. So let's look at the principle of moment. Now what do you understand by principle of moment? How can you define this statement? So principle of moment is defined as, so we can state it in fact. So in most cases they will tell you to state the principle of moment. How can you state it? So it's a law, so which states that for a body to be in equilibrium, the sum of the clockwise moments about any point is equal to the sum of the anti-clockwise moments about the same point. Right? In other ways, so we're simply saying if a body is balanced, so we're simply saying it is balanced, meaning it is in equilibrium. The body is balanced. We are saying total clockwise moment should be equal to, so I'll say should be equal to total anti-clockwise. So total anti-clockwise moment. So this is the principle of moment. That is how, and there is an experiment that you can do to observe the principle of moment, but we're not going to do that. Instead, we're going to go into calculations. We'll look at an example that will help us to understand the principle of moment. So let me put an example here. Now suppose we have this question which is telling us to calculate, so let's say calculate F. So calculate F. So now let's do this. We have a diagram here. So the diagram is of this nature. Then we have a pivot here, somewhere here. This is where the pivot is. Then from there we have a distance from that point to that point. So this distance is 0.4 meters. Then we also have another distance from that point to that point. Then this distance is 0.5 meters. So from there we have a force here. We have a force, then we have another force here. Now this one has been given to be 100 newtons, then the other one is unknown, so it's the one that we're looking for, force F. How can you find force F? Using the principle of moment. Now this is simple and straightforward. What we have said for a body in equilibrium, meaning the one which is balanced, the total clockwise moment should be equal to the total anti-clockwise moment. So what it means is that, so we say, I'm going to say it's one and the same. So if I say anti-clockwise, if I say total anti-clockwise moment should be equal to total clockwise moment. So therefore we know moment is calculated by saying force multiplied by distance. So I'll say should be equal to force multiplied by distance. So the force, what is the moment on the anti-clockwise? So we start with the force. The force we don't have, we have F. Then so the anti-clockwise in that direction, so we have the distance, which is 0.5. Then the force is what on the clockwise part. So on the clockwise part, which is the side, we have force, which is 100. Then we have distance, which is 0.4. So 0.5 times F, this becomes 0.5 F. Then 100 multiplied by 0.4, we get 40. Then I'm going to say divide by 0.5. When this side divide by 0.5. So 0.5 is gone, 0.5 is gone. Then our F is equal to 0.5 into 40. So that is giving us 80 newtons. So 80 newtons is our force for that question. So that's basically how you can find force when you are given a diagram that involves a principle of moment. We're going to look at another example. This one will serve as the last example that will look at the principle of moment. So now example number 2. Suppose we have a diagram. Now this diagram, so I'm going to do this. We have that, we have that. Then I'm going to put the pivot here. This is where the pivot is. Then we have 3 forces in this time around. So we have a force here which is having 5 newtons. Then we put another force somewhere there. So let's say this is having 3 newtons. Then another force somewhere there which is 1 newton. Then what we're going to do is from the pivot here, so this is where the pivot is, there is a distance. So from here to there is a distance that we're going to call distance D. Then again from the pivot to where the 3 newtons is, we're going to put another distance that we're going to put 1 meters. then from the same point, the pivot where the 1 Newton is, so I'm going to put another distance. So let me say from there to there, this is 2 meters. Then the question now is being asked to say calculate uh, distance D. So how do we calculate distance D? Now distance D can be calculated by using what we call the principle of moment. Now remember, in the principle of moment, we said the total anti-clockwise moment should be equal to the total clockwise moment. So the total anti-clockwise moment should be equal to the total clockwise moment. So the total anti-clockwise moment, so there we have, so I'll say force times distance. Then on the clockwise side, what we have two forces, so I'm going to say force 1, so multiplied by distance 1 plus force 2 multiplied by distance 2. So on the anti-clockwise side, the force is 5, on the distance is D, then on the so that one was on the anti-clockwise, so this side on the anti-clockwise. Now on the clockwise, we have one of the forces that we're going to call the first force, which is 3 newtons, and the first distance from the pivot is 1 meter. Then I'll say plus the second force is 1 newtons multiplied by the second distance, which is 2 meters. So 5 times D, this will give us 5D. 3 times 1 is 3, 1 times 2 is 2. So this will be 5D, 3 plus 2, that is 5. Say divide by 5, when here divide by 5. The 5 is gone, the 5 is gone. Then D will be equal to 5 into 5, it is 1. Since it is distance, the unit for distance is meters. So that is how we can find that one. So basically, that is how the principle of moment is. Now I'm going to put just a question that you can try out and see how you'll be able to go about it. So suppose you have a diagram. Okay, so we can start with such. So let's say the question, we have that diagram there, then we have a pivot there, then we have a 5 newton force there, okay, then we have a 3 newton force there, then here we have a force that we're going to call F that we don't know. Then from this pivot to that, we have 1 meters apart. So from there to there it is 1 meters. Then again from here, from the pivot to that other end, it's also 1 meter. Then from this pivot to that force, so we say it is 2 meters. So let me say 2 meters here. So now the question is saying we find the force. So let's say find F. So how can you find the force F? That is what I want you to try out.